Hydroelectricity. Electricity is everywhere. It is in the air and it is in us. Discover its power in Basic Electricity. Did you know that rushing water can make electricity? See how it's done in Hydroelectricity. Energy from the sun and wind can also create electricity. Discover the power of these natural resources in solar and wind power. Segment 1. Basic Electricity. Electrons on the move. The ancient Zulus of South Africa believed that lightning was an evil bird, and whenever it streaked across the sky, they ran in terror. If lightning struck an animal, the Zulus would not dare eat it. And if lightning hit one of their huts, they would burn it to the ground, if the lightning had not already done so. Mystery and myths surrounded lightning for centuries. Today, we know that lightning is not an evil bird, or fire in the sky, or punishing blows from an angry god. Lightning, we now know, is electricity. Electricity is in the air and in the clouds. It's also in the grass and in the trees. Although we don't usually feel it, electricity is even in our hair and in our clothes. It's everywhere because electrical energy is stored in atoms, and everything is made of atoms. These building blocks of the universe are so tiny that a single grain of salt contains many billions of them. Up close, an atom looks like a miniature solar system, but instead of the sun, a nucleus is in the center. Orbiting the nucleus are not planets, but particles called electrons. Most of the time, electrons stay with one atom, but sometimes they leave that atom and jump to another one. And when electrons move from atom to atom, something happens. Electricity! It doesn't take much to make electrons travel. The bumping or rubbing together of two different things can make it happen. In a thunderstorm, winds whip the air and clouds, causing countless water droplets, ice crystals, and bits of dust to collide. Electrons get bumped from atom to atom. This causes a charge to build up in the lower part of the thunderstorm cloud. When the charge gets too great, lightning bursts from the cloud toward the earth. This is no evil bird. This is an electrical discharge. The churning and bumping of atoms makes electricity. But what else can make electrons move? Magnets. Magnets exert an invisible yet powerful force that pulls iron, steel, and other metal objects towards them. Just moving the invisible force of a magnet near a wire will make electrons flow. The electrons will continue to move in the wire as long as the magnet is in motion. Batteries too can make electricity. Chemicals inside the battery cause electrons to move. Electrons flow from the battery through the wire and into the globe. It takes trillions of electrons, all on the move, to make a globe light up. And they must move in a circle called a circuit. In this circuit, electrons flow from one end of the battery through wires, including the tiny wires inside the globe, and back into the other end of the battery. To keep the globe lit, electrons must flow in this circuit over and over and over again. If the circuit breaks or gets interrupted, electrons stop moving. With no moving electrons, there is no electricity and no light. Copper, iron, and other metals are often used to make wire. That's because they are good conductors of electricity. The electrons in metals easily jump from atom to atom. Electricity flows through metals like water flows through a hose. Not so with rubber and plastic. they slow down or even stop the flow of electrons. That makes them good insulators. Plastic wrapped around wire insulates it, keeping the electricity in and away from us. For most of Earth's history, electricity could do little more than light up the sky. But since the mid-1800s, people have put the power of electricity to work. After all, electricity is a form of energy, and it can power all kinds of amazing things. But be careful. Electricity can flow through your body and shock you. Some wires carry enough electricity to kill a person. Always put plastic, rubber, or some other insulator between you and electricity. A stroke of lightning shows the power of electricity to make light and heat. Enough light to illuminate the night sky, and enough heat to make the air around the lightning 6 times hotter than the sun. By studying lightning, we have learned a lot about electricity. We know what it is, and we know how to make it. By making it, we can turn a place like this into a place like this. Because electricity is power, places that make large amounts of electricity are called power stations. Some power stations burn fuels such as coal, oil, or natural gas to make electricity. Hydroelectric power stations use the energy of falling water, and solar power panels use the sun's energy. But all power stations and solar power panels make electricity by making electrons move. When you think about electricity, think electrons. Electrons on the move. Make a list of objects in and around your community that use electricity. Think about areas that may use electricity, such as local stores, your home, and your school. Don't forget to include objects that run on batteries. Segment 2. Hydroelectricity. Electricity made by the power of water. Water is many things. A cool, refreshing drink, a puddle in the road, a slow-running stream, a stormy sea. Water helps plants and flowers grow and has the potential to cause great destruction. Water is all of these things and something more. A tremendous source of power. In a way, water has muscles just like you and me. It can do work, and lots of it. You can see water's power as it easily moves heavy logs and even cars along its path. Throughout history, people have figured out ways to make water work for them. A device invented long ago called a water wheel made good use of water's power. A water wheel looks like a wheel, but it has blades or pedals like those of a fan. Water rushing past the water wheel pushes the blades and causes the wheel to turn. This water wheel is connected to a system of shafts and gears located inside a building called a mill. The gears are connected to stones. When the gears turn, so do the stones. The stones grind grain to make flour. But did you know the power of water can also make electricity? Electricity made using the power of water is called hydroelectricity, because hydro means water. Hydroelectricity refers to the electric power generated by water. But how can the power of water, even lots and lots of water, power a globe, or a computer, a home, or even an entire city? How is water used to make electricity? It begins with harnessing the flow of water. Look at this stream, for example. The water flows and flows. But if the path of the water is blocked by a barrier, the water stops flowing and the water level rises. This extra height gives the water more power and more muscle. A barrier that is constructed to block the flow of water is called a dam. Most dams are gigantic structures built to stop the flow of rivers much larger and stronger than this. To stop a big river, you need a big dam. One of the world's largest dams is part of a hydroelectric power station located in South America. It is called the Itaipu Power Station. This barrier lies on the border between Brazil and Paraguay. The Itaipu Power Station is an 8-kilometer-long structure that spans the Paraná River. A hydroelectric power station is the place where water power is used to make electricity. Inside a hydroelectric power station, there are many gears, valves, pipes, and wires. 7 main elements work together to make electricity. Some of the names of these elements you may know, others may be new to you. These elements are water, dam, penstock, turbine, shaft, generator, and magnet. But how do these 7 main elements work together to create electricity? Now that we know the terms, let's take a look inside a hydroelectric power station to see how it all works. Water flowing down the river is blocked by a dam. It took over 10 years to build a barrier strong enough to hold back the water of the Paraná River. The water pressing hard and heavy against the dam gets released through large cubes called penstocks. The Itaipu Power Station has 18 penstocks. Moving with much force, the water is funneled through the penstocks past machines called turbines. A turbine is similar to a water wheel. Its blades are turned by water. Lying in the path of rushing water, turbines spin completely around more than 100 times every minute. A shaft is a strong pole that connects the turbine to a generator, the machine that generates electricity. Makes sense. Generators generate the power. Built inside this generator is a magnet. The magnet is surrounded by coils of metal wire. When the shaft spins, so does the magnet. When the magnet spins, electricity is made. The spinning magnet causes electrons to move in the wires. Making electrons move in the wire is the key to making electricity. What are electrons? Electrons are tiny particles found in atoms. Atoms are everywhere. They are in the building blocks that make up everything. You, me, books, clouds. Everything is made of atoms. Hydroelectric power stations use wire because it is made of metal. And metal is a good conductor of electricity. Let us review how the power of water is used to make electricity. It is the water that turns the turbine, that spins the shaft, that turns the magnet inside the generator. When the magnet spins, electrons move. This is how electricity is made. But how does all this electricity get to homes, schools, and offices across the land? It flows from the metal wires around the magnet in the generator to other larger wires. Outside the power station, thick cables held up by huge towers connect the power to the people. Today, hydroelectric power stations supply about 1/5 of the world's electricity. Without the power of rushing water, the lights would go out across much of Brazil and Paraguay. The Itaipu power station produces nearly 1/3 of Brazil's electricity and more than 2/3 of Paraguay's. Throughout the world, many people use water, not just for drinking and bathing, but for making electricity. Using water power, they heat their homes, cook their food, and light their streets. Once water flows through a hydroelectric power station and does its work, it moves downstream. It is not used up. That makes water a renewable resource. Over and over again, it is replaced by more water. Good thing. People all around the world rely on water, the natural resource with muscle. Find out the major source of electricity where you live. Does this source use water, coal, the sun, a nuclear reactor, or something else? Segment 3. Solar and wind power. Electricity made by the power of the sun and wind. Energy is heat, light, and motion. Energy makes things grow. Energy is all around us. Energy makes things happen. Electricity provides the energy to turn on a light, a television, to run our machines, and much more. Where does electricity come from? Most of the world's electricity comes from the stored energy found in coal, oil, and natural gas. Large power stations burn this fuel, releasing its stored energy to produce electricity. But what if you are among the 2 billion people around the world who are not connected by wire to a power station? Is there any other source of energy that can make electricity? Yes, the sun. Our Earth is traveling around a huge ball of energy. The sun is like an enormous power station that makes life on Earth possible. When the sun rises, flowers open. Reptiles warm up and become active. Plants convert sunlight into food. Even when we sit in the sun to get warm, we are using solar energy. Every day, the sun sends out a huge amount of energy that fuels our life on Earth. People have discovered many ways to harness the energy of the sun. A simple solar collector system can provide people with heat and hot water. But how is the sun's energy turned into electricity that we can use in our homes? Solar electricity, or electricity made from the sun, is made by special devices called photovoltaic panels. Photo means light, and a volt is a measure of electricity. Photovoltaic panels convert the energy of the sun directly into electricity. These panels can be used in many places, including the roof of your home. Photovoltaic panels are made up of many smaller sections called solar cells. When sunlight hits the solar cells, electrons begin to move and flow through the connecting wire. This flow of electrons is what we call electricity. And electrical energy created by the photovoltaic cells can be stored in a battery and used at night when there is no sun. Photovoltaic panels are used to convert the sun's light into electricity all around the world. Even in outer space, some satellites orbiting the Earth use solar panels to generate their own power. The sun plays a part in another source of energy that can be used to make electricity: the wind. Wind is air in motion. Wind is caused by the uneven heating of the Earth's surface. Wind energy can be put to work. A boat with a sail uses the wind to push it through the water. A farmer may use wind energy to pump water from wells for thirsty animals. Like water or light from the sun, wind is a natural resource with muscle. Each can be converted by a tool to make electricity. A wind machine converts the energy of the wind into electricity. A wind machine has blades that spin round and round in the wind. It is placed on a high tower where the wind blows faster than it does closer to the ground. The force of the wind is used to generate electric power in much the same way water is used to create hydroelectric power. The energy of this natural resource powers a generator in the wind machine. How does a generator make electricity? The wind power causes an iron bar wrapped in wire inside the generator to spin very fast. This creates a magnetic force that in turn causes electrons in the wire to move. And what happens when electrons move? Electricity. Electricity travels through metal wires connected to the generator, down the pole and along other larger wires, where they run to nearby homes and businesses. Wind machines are grouped together in what are called wind farms. That way, they can create enough electricity to supply many people at one time. Energy is all around us. Energy makes things happen. Around the world, people use the energy found in the heat and the light of the sun, and in the motion of the wind, to create electricity. The sun dries your clothes. The wind cools you down. Make a list of other things which are affected by the heat and light of the sun or by the motion of the wind.